This video is talking about proofs with parallel lines, and I actually am doing something interesting with this video. I am purposely recording it before I've written these proofs because I think the most useful thing for other people to see is to watch somebody go through the thought process. So a proof in general is just showing that something's true and explaining it in a logical way that can't be picked at or fought, that people can't find holes in. So there's not necessarily one way to do a proof, it's just a logical explanation for why something is true or isn't true that nobody can find any holes or problems with. So for example, I have this picture and statements here, and it says given that L is parallel to M, so I'm assuming that these two lines are parallel. And then it also says given that angle 2 is equal to angle 4. So this angle is equal to this angle, and I'm assuming that these two lines are parallel because that's what's given to me. So what's given to me, I don't have to prove. I don't have to explain that. That's just true because it was told to me. But what it wants me to prove is that angle 4 is congruent to angle 3. So first I'm just going to kind of look at it. I'm not going to write anything down, and I'm going to say, okay, well, angle 4 is not even in this area, so I'm not even going to worry about it for right now. But what else is angle 3 equal to? Well, the only thing I know, I have angle 2, I know that's equal to angle 4. Angle 3 and angle 2 are alternate interior angles, and I know that they are equal to each other because these two lines are congruent. I mean, parallel, excuse me. So these two angles have to be congruent. Well, if 2 and 3 are the same, and 2 and 4 are the same, well, then all three of them have to be the same. That's the only way that makes sense. So 4 has to be equal to 3. So that's kind of the way I logically think through a proof before I start writing it. So I'm going to show you two different ways you can write this. The first is often called a two-column proof. So I'm just going to draw two columns. This column is our statement, and then this column is our reason. So I'm going to start with whatever was given to me. So I was given that L is parallel to M and angle 2 is congruent to angle 4. And my reason for that, I can literally just say given. That was given to me. And then the next thing I decided was that angle 2 and 3 are equal to each other. So my next statement is going to be angle 2 is congruent to angle 3. Why? Because they're alternate interior angles are congruent. That's my reason for saying those two are equal. So I know that 2 is equal to 4, I've already said that, and I know that 2 is equal to 3, I've already said that. So I can say from there that angle 4, that kind of looks like a 9. Let me fix it so we don't get confused. So angle 4 is congruent to angle 3 because angle 2 is congruent to angle 4 and angle 2 is congruent to angle 3. Therefore, angle 3 and angle 4 have to be congruent. So that was a pretty simple one. I just kind of went through, and that's the reason why. Now, I think a lot of people like proving this way because it's an organized way to get through their thoughts. I go from this step to this step to this step. These are the reasons that led me from here to here to here. Other people, I think it's easier for them to just explain it. So I call the next type of proof a paragraph proof. So I'm going to start by saying, okay, I know that L is parallel to M and angle 2 is congruent to angle 4. Angle 2 is also congruent to angle 3 because angle 2 and angle 3 are alternate interior angles. And alternate interior angles are congruent. well, and this, again, I actually prefer this type of proof because I feel like it's more like I'm just explaining it to you. I'm not worried about like making sure my steps are perfect and my reasons are perfect. I'm just giving you an explanation. I'll go back through and read it, make sure that it makes sense and that there's nothing that you could argue with. So then I'm going to say, well, if angle 2, or I'm actually going to switch the order on that. I think it'll make more sense. So if angle 4 is congruent to angle 2 and angle 3 is congruent to angle 2, then angle 4 must be congruent to angle 3. And that's what I was trying to get to. This was what I was setting out to prove. So both of those proofs are acceptable proofs. I like this one better because I feel like it's more, I'm just explaining it to you, here's my logic, try and fight it. And I think that's the best way for you to get better at proofs, for you to write one and then have someone read it and make sure they think that it makes sense and that they can't find any holes or arguments against it. I'm going to show you one more example. So my next one, I have given that L is parallel to N. So that's all I'm given this time, is I know that L and N are parallel. Okay. And then angle 3, I'm trying to prove that angle 3 plus angle 6 is equal to 180. So here I have angle 3 and I have angle 6. So I know that these two lines are parallel. So I'm going to start with that, and I'm going to start with a paragraph proof this time, and then I'll do a 2-column proof. So starting with that, I say, okay, I know L is parallel to N. Then if I know that, angle 6 and angle 3 are consecutive interior angles. What do I know about consecutive interior angles? Okay, so I know consecutive interior angles are supplementary. And then what do I know about supplementary angles? Well, supplementary angles add to 180 degrees. So based on my logic so far, I know that angle 6 are consecutive interior. I know that consecutive interior are supplementary. I know that supplementary angles add up to 180. Thus, the measure of angle 6 plus, or I guess I should put it in the order it has me prove it in. So I'll say the measure of angle 3 plus the measure of angle 8. And in fact, I'm going to erase again. So this is why I think it's good that I haven't done it yet, because you can kind of learn from my thoughts. It's kind of important to show that this is what I've proved. I'm going to use the word thus. So because of all of this, thus, based on all of this, the measure of angle 3 plus the measure of angle 6 must equal 180 degrees. So I'm going to go back through. Okay, I know these two are parallel. If they're parallel, then these two have to be consecutive interior angles. If they're consecutive interior angles, then that means they're supplementary. Supplementary angles add to 180 degrees. These thus must add to 180 degrees. So I think that's a solid proof. I can do that same proof in a 2-column method. So I have my 2 columns, I have my statement, and I have my reason. So I'm going to start with what's given again. So L is parallel to N, and that is given. So because L is parallel to N, I know that angle 6 and angle 3 are consecutive interior angles. And I know that because of the definition of consecutive interior angles. So you may have to appeal to definitions sometimes. And then, so this is my first statement, second statement, third statement. Angle 6 and angle 3 are, and I'm going to actually go right to angle 6 and angle 3. I'm going to go right to the end right here, and I'll show you why. Angle 6, well, no, I'll just stick with how I did on the other one to avoid confusion. So angle 6 and angle 3 are supplementary. Why is that? Because consecutive interior angles are supplementary. And if they're supplementary, that means they add up to 180. So I can go right to my final thing. The measure of angle 3 plus the measure of angle 6 is equal to 180. And how do I know that? Well, from the definition of supplementary angles. So I will be honest with you, I am better at doing paragraph proofs than I am at 2-column proofs, but both are acceptable. So if you prefer a 2-column proof, you can use a 2-column proof. If you prefer a paragraph proof, you can use a paragraph proof. But I think the most important thing is to just think through the problem, think, why did I do that? Why did I do that? From step to step to step, and be able to explain yourself all the way up to whatever you're proving.